The next one is on the new power plant constructions. The third one is on CCS site. CCS now, they store a lot of almost concentrated CO2. Some of them may want to apply this technology to truly remove the CO2 instead of keep it there for eons, forever. And lastly, now some of the locations or some of the CO2 emitters, they may not be able to get to the CS pipelines. So we could design a portable unit for them to use. And that's pretty much conclude my presentation. And if you have any questions, we could talk about it in the Q&A sections.
Thank you. It is a pleasure to be here, and for me it truly is a coming of home. This is my home state. I did grow up here. It's a pleasure to be here with many of the mentors. It doesn't surprise me to see so much wonderful things about energy coming out of this region with people like Dorothy Runnels. Her and Harold, as you may remember, were true leaders in this area. Thurman Duncan, who taught me when I was that little, but talked about energy and the policies, Hop Graham, Robert Cottle, and it's a real pleasure to be here. Robert called and he said he wanted me to talk about everything you want to know about smart grid in 15 minutes. And I've just been advised I got 5 minutes, so we'll try to accomplish that. First of all, why is it important? Why is smart grid important? What we're talking about with smart grid is simply putting intelligence into the grid. Studies have shown that if you make the power grid intelligent, I'm talking about from the appliance to the generator, you can save as much as 20 to 25% of generation plants and transmission lines. Now, how awesome is that number? You heard from our speaker at Ford Motor Company talk about what they've done with an automobile by putting intelligence and smart and making an engine more efficient. All a power grid is a single machine. From your refrigerator to your appliance to the nuclear plant, it's all connected as a single machine that operates at the speed of light. You are part here of the Eastern Interconnection, the world's largest machine, 600,000 megawatts. It's all operating at exactly the same frequency. It's a single machine. So we want to make that machine more efficient by putting smarts into it. And if we can, you can reduce the amount of generation and transmission needed by as much as 20 to 25%. And that's a noble goal. And I had the privilege of working with Senator Bingaman in the 05 Acts and again in 07, where there was enabling legislation to try to move this forward, to move this country to be able to develop a smart grid. First of all, why is it important? What's happening? First of all, what is a power grid? What makes it work? It works simply because it has to be in balance. Electricity is a speed-of-light product. It's the only product that isn't produced until the very instant someone wants to consume it. It operates at the speed of light, so it has to be in balance. If it's not in balance, we don't have power, and that's not a good thing. For over 100 years, we kept it in balance by simply saying we need to have more generation available to meet whatever the demand is at that point in time. And if you look at this as a scale, what is happening? The customer any minute says, I'm going to put on more weight, I'm going to add 5 pounds, 10 pounds, 30 pounds, 50 pounds, or take it off. And on the other side, you had to always make sure you could keep that scale balanced by adding generation plants or transmission lines. So how do you do that? You overbuild. You put more on there, you add more, you try to anticipate and forecast. And for 100 years, that's how we worked with the power grid. And that's how the power grid worked and worked well. But what became apparent is that the grid that we've built today is a dumb grid. There's very little smarts, the transformers, the equipment, the reclosers, the lines. They're just equipment hanging out there. There's no smarts in it that makes it all work. And almost everything you look at, every electromechanical device in society has got smarts built into it. You look at our telephones, you look at our appliances now that can communicate with the internet. Everything has got smarts built into it. This synchronized thing called an electrical grid can have smarts built into it to make it much more effective and efficient. This one graph, you can't read it here, but when you get it and you look at it, it shows you all the functions that are in the grid today, and you can see how dumb they really are, and what it can be achieved if we can make it smart and efficient and effective. Probably one of the best ways to look at this is a typical engineer, one-line diagram. Why is it important? If you look at the way the grid operated yesterday, the utility built the lines, and you had your residences and so forth out there drawing on the electricity. And since 1978, in the PERPA days, there's a few little photovoltaic cells put out there or solar hot water heaters or something, and that was a power grid. Today, it's a little bit more complicated. We've got a lot of wind and other kinds of generation floating around out there, all trying to be balanced. And things are starting to come up at the residential and the home and the small commercial level where you're adding different devices and ideas are coming up to be able to make the grid more efficient. But if you look to the future, where we're into is a total interactive machine where you have all these devices working on the generation side and everything within the home communicating and smart, working together as a whole. You see it go the meter where things go two-way, net metering, which is why SPS mentioned you got that issue. When you're selling power back to the grid, as you can see in the tomorrow one-line diagram, you're using another system that you don't own to deliver your power out and get paid for it. So you have an interactive network that's moving forward in the future, and that's where we want to be to make this thing called electricity and the electricity grid more efficient. If we look at the power plants now, we have a lot of them. In PJM, we had over 9,000 power plants. I mean, every kind of plant imaginable that can bid and trade and provide energy into the system. And we got a lot of good ideas about how to make the plants more efficient and the communications around that so that we can keep that grid in balance with all these multiple resources based on the price and keep the grid in balanced. But if we look to the future again, we're now talking about how to get that whole network more efficient and effective, how to measure every device and have all those devices communicating such that you have price response customers coming in. You talk about plug-in hybrid vehicles. How do they fit into the grid? Where's the economics? How can you get paid for the services you provide? To keep a grid in balance, you've got a lot of dynamic going on. And currently, the only ones participating in that economic of that balance are the utilities. But I will tell you, in operating a power grid, it's just as important to have a whole bunch of refrigerators managing frequencies, and sometimes better than having a generator. The experiments were done in Seattle where they tied in over 10,000 refrigerators and actually found out they could control system frequency better than having a generator do it. And so the question is, how do you pay people to do that? And these little devices cost like $5 each. So you can participate in that grid to keep the grid in balance as you become more interactive and move forward to the future. So why is it so complicated? Well, it's complicated because over 100 years our history's grown up into silos. We have over 4,000 different utilities involved in the generation, transmission, and distribution of electric power in North America. The North American grid is connected with Canada. You have 2 countries. You have 50 states. You have 8 reliability councils involved. You have the federal government, you have the state government, and you have some utilities that don't report to anybody, like TVA, that just reports to the United States of America. But it's a single machine. So how do you make that single machine become more effective, efficient, and smarter? It takes legislation, and this is where Senator Bingman was a strong leader in being able to put that in. We're trying to get rid of these silos, find a way that this whole network can be more efficient, can be smarter, and move forward with the speed of light. But probably one of the most exciting things to come out of it is some studies done by IBM. IBM took a hard look at what's happening with electricity, and they compared it to other consumerized products. And one of the things IBM compared it to was television. And they drew a number of graphs showing the history of the development of technologies. And you think about it. Remember the phone, and you had the dial-up and all those sort of things going on, and where's the phone today? Well, they looked at television. And they said, if you look at television, what you and I did as a consumer, at first we were passive. They told us what we could have, what our networks were. And then you moved out of that passiveness till you started having some sort of interactiveness to be able to control what you want. And then finally, you become a full participant into the power grid. And IBM says the same thing is happening to electricity. You and I, consumers, are starting to be more engaged. You understand the price. You want devices. You want to control your own appliances. You want to get paid for the value you bring to the grid. You want to get paid for the value you bring your hybrid car. That's what a smart grid does. It enables the consumer for the first time ever to be a full and active participant. This is a sea change. It's a change that's happening, and it's a change that's real and taking place not only here, but throughout the world. And these IBM studies, I think, are quite telling in what the future is going to be as this smart grid becomes more and more enabled. This is one of my favorite graphs, and I put these in here for the students that are here today. If you look to the future, what we're doing now is you're going to have a new network. We all know about the internet. As the smart grid becomes enabled, you're going to have a networked electrical infrastructure where all these things are communicating and talking to another, where your devices will be talking directly to the grid, getting paid for what they do, and being able to manage in a more efficient and effective way. And in this networked economy, this networked electrical grid that we're all part of, it becomes extraordinarily exciting. And for the students, there's fields that are available to be engaged in here are absolutely tremendous. I've probably talked to over 500 companies since I retired 2 years ago that all have a great idea trying to integrate it into the power grid, and the question is, how do we do it? Some of the better ideas have came from some people I talked to at Disney, and they were looking at how they use their visualization techniques, and I found companies that were actually hiring people that are programming video games, and they're doing it so that as this grid becomes smarter and more sophisticated, they can have the devices so that you can work with them interactively off your TV and control your grid using icons. And it's just absolutely extraordinary, some of the things that are coming down to do that. If we look at this, it's a bit fuzzy, I understand, but you know, in the past, this top bar up there was just the utility saying how to get my generation, how to get my rate recovery, how to build enough plants, enough transmission lines, and we'll forecast and say this is what the customer's going to do. And now we've came down to, we've got solar, we've got wind, we've got biomass and algae, all these different things taking place, all trying to find their business case and how to interact to that grid. But this demand side, the other side of the equation that can be managed and controlled and interactive through smart grid technologies opens up a whole nother world as we integrate this together into the smart grid. And then finally, it's no longer going to be a scale imbalance. We're networking all this equipment through communications and the power of the communications that we have today. And as all this becomes networked and communications and talks, and we squeeze the efficiencies out of this single motor that we're all a part of, and those efficiencies are where we then derive the value for carbon, derive the value for efficiency, and also put you in charge of your own economics, where not only are you paying for electricity, but you're also getting paid for the value that you bring to the grid. And that's the hope and the goal of the smart grid. So I hope I got that done in 5 minutes and met your time schedule.